Hello, good day learners. I am Miss Karen Guanzon and today I'm going to be your math teacher. So, before we proceed to the discussion, let me tell you first what is math. Well, as you all know, mathematics is all around us. It is an area of knowledge that includes topics as numbers, formulas, and related structures, shapes, and the spaces in which they are contained, and quantities and their changes. There are many branches of math, but today I am going to tackle my favorite topic in math, which is the basic algebra. Basic algebra covers the simple operation of mathematics like addition, subtraction, multiplication, and division involving both constant as well as variables. I know you're familiar with x and y variables. We'll be focusing on integers, polynomials, algebraic expressions, and algebraic equations. So let's proceed. Integers. Integers are whole numbers from set of positive, negative, and zero numbers. For negative, we have -1, -2, -3, -4, and so on. And for positive, we have 1, 2, 3, 4, and more. And for zero all by itself. As you can see, we have the number line containing 0, the negatives, and the positives. As you can see on the left, the numbers which has negatives are gradually getting smaller and smaller. And to the right, we have the positives. The numbers are gradually increasing 1, 2, 3, 4, 5, 6, 7, and up. That's integers, and this is the number line. Now that you know what is integers, let's proceed to solving it. As you can see, we have here the rules in adding integers. First, we have if the signs are same, add and keep the sign. If it is both positive, the result will be positive. Like positive 2 plus positive 2 will be equal to positive 4. And if it is -2 plus -2, the answer will be -4. Keep the sign. The second rule, if the signs are different, subtract and take the sign of larger absolute value. Let's take the first example so it will be easy for me. 4 plus -7. Subtract the 2. 7 minus 4. It will be equal to 3, of course. And take the sign of the larger value, and the larger value is 7. 7 has negative, so the answer will be negative, and their answer 3, -3. So 4 plus -7 will be equal to -3. We have there the second example. The first rule is applied in the second example. -3 plus -8. So add the 2, 8, 9, 10, 11, and their signs negative. The answer will be -11. And for the last example, we have -2 plus 6. The second rule, subtract the 2. 6 minus 2 will be equal to 4, of course, and take the sign of the larger value, which is the 6. 6 is positive, so the answer will be positive, and the answer for positive 4. So -2 plus 6 will be positive 4. Are you getting it right? If you still don't get it, let me share you a video of further explaining the procedures in answering the given examples. So let's proceed. So this is the first example, which is the 4 plus -7. Since the signs are different, we're going to have the second rule in adding. Subtract the absolute value. The absolute value of 4 is 4 and the absolute value of -7 is 7. Now subtract the two. 7 minus 4 is equal to 3. Now copy the sign of the larger number. Obviously the larger number is 7, -7. Since it has negative, put the negative sign in the answer, which is the 3. So the answer will be -3. Now to the second example, which is -3 plus -8. As I said earlier, this is the one of the easy one. If both are negative, just add the two and copy their sign. So 8 plus 3 is equals to 11. Now they are both negative, so copy the sign -11. So -3 plus -8 is equal to -11. See, easy as that. For the last examples, in this case we have -2 plus 6. Same as the first example, we have to find the absolute value since they have different signs. The absolute value of -2 is 2 and the absolute value of 6 is 6. Subtract the two. 6 minus 2 is equals to 4. Now the larger number, which is the 6. Copy the sign of the larger numbers, 6. Since it has positive, the answer will be positive 4. Sorry, that. So -2 plus 6 is equals to positive 4. Now we're done in adding integers. We're now on subtracting integers. Well, add the opposite of the subtrahend. Well, subtracting integers is a little bit more tricky than adding integers. So, for you to able to understand it more, let's take this example so you'll understand it. We're on the first example, which is the 8 minus -2. This is a little bit tricky, so listen carefully. So the process is copy the first integer, 8. Next, get the opposite of the second integer. The opposite of -2 is 2. And when you add the two, 8 plus 2, we have 10. If you're a little bit confused, in subtracting integers, you have to add the subtrahend. So 8 plus 2 will be 10. That's it. We're now on the second example. -10 minus -4. So the rule, copy the first and add it to the opposite of the subtrahend, which is 4. The opposite of -4 is 4. Now if you remember the rules in adding integers, subtract the 2 and copy the sign of the larger number. So we have 10 minus 4, we have 6, and the sign of the larger number, which is the 10, the negative, we have -6. Do you get it? Now for the last example, we have -12 minus 7. Same process as the first and the second. Copy the first and add it to the opposite of the subtrahend, which is -7. So we have -12 plus -7. Now add the two. 12 plus 7, we have 19, and in the sign negative. So the answer is -19. In subtracting integers, you must know the rules in adding integers because it is applied when you subtract integers. That's it. Now we're on the exciting part in integers. Sure. It is the multiplying and dividing integers. Multiplying and dividing integers are just the same. So in dealing with negative numbers, you will always end up with two negative numbers and one positive numbers. As you can see here, if you have both positive or positive times positive will be equals to positive. Now if you have positive times negative or negative times positive, you will always end up with negative answers. Now into the fourth one, negative times negative, you will end up with positive, or negative times negative is equals to positive. So let's take these examples. First example is negative 6 times 2. Remember that in dealing negative numbers, you will end up with two negative numbers and one positive numbers. This time, since we have negative times positive, you will end up with negative. Now, multiply the two. 6 times 2, we have 12. So, negative 6 times 2 is equals to negative 12. Now on the second example, we have negative 18 times negative 2. Remember that if you're multiplying both negatives, you will end up with positive. Now multiply the two. 18 times 2, we will have 36 positive. Since both are negative, the answer will be positive 36. Now we're on the third example, 10 times negative 5. It is the same as the first example, but rearrange the negative is now on the subtrahend. So multiply the two. 10 times 5, and the sign will be negative since positive times negative is equals to negative. So 10 times negative 5 is equals to negative 50. So that's the answer. Actually, multiplying integers is one of the easiest too, aside from adding. Next we have dividing integers. Well, it is the same as multiplying integers, so you just have to divide it. Since we have negative 24 divided by 8, one negative and one positive. The answer is positive, since negative divided by positive is equals to negative. So divided now, 24 divided by 8, we have 3. So the answer is negative 3. Negative 24 divided by 8 is equals to negative 3. Now the second examples for dividing integers, we have 75 divided by negative 5. Now we have positive divided by negative. So 75 divided by 5 is equals to 25. So the answer is negative 25. As for the last example in dividing integers, we have negative 76 divided by negative 4. Since both are negative, so the rule is negative divided by negative is positive. So the quotient will be positive. So 76 divided by 4 is equals to 19. So negative 76 divided by negative 4 is equals to 19. Positive 19. Do you get it? Since we're done on integers, let's now discuss polynomials. So what is polynomials? Well, polynomials are algebraic expressions that consist of variables and coefficients. Poly, that means many, and nominal, that means terms. There are types of polynomials. We have here the first one, monomial. monomial has only one term. You have your example x, 3x, 2, 4y, and more. And we have here the second type, binomial, which consists of two terms. We have here the example negative 2x plus 3 and x plus 2. They have two terms. And we have the last one, trinomial, which consists of three terms. Example, 2x squared plus 3x plus 6. Remember that polynomials are divided by plus signs and minus signs. And as you can see here, in the examples, it is divided by plus signs. So, in adding polynomials, you only have one rule. Add the like terms. Now, let's answer this following example so you can further understand adding polynomials. For adding polynomials, we have here the example 2x plus x. In this case, we have the same variable, which is the x, and there's no, the exponent is only 1, so they have the same. Add the numerical coefficient 2 plus, there will be 1 here, 2 plus 1 is equals to 3, and copy the variables x, so the answer will be 3x. Second example, we can see that there's no like terms. So in this case, we have to just copy them, x plus 3. So if there's no like terms, just copy it. And as for the third example, you can see that even they have the same variable, we have to consider the exponent here. And the first term we have 2x squared, the exponent is 2, and the second term has only one exponent. So we have to just copy them, the expression 2x squared plus x. We don't have to combine them since they don't have the same exponent. And here's the last example. We have here 2x squared plus x squared plus x plus 3. We can see that there's a like terms, which is x squared. So we have to add the two like terms. 2x squared plus x squared is equals to 3x squared. Then, since there are only two like terms, we just have to copy x and the 3. So the answer will be 3x squared plus x plus 3. Now you know how to add polynomials. Let's proceed to subtracting polynomials. In subtracting polynomials, we have two rules. Subtract like terms, just like adding like terms. And the second one, the signs of the superhand changes from positive to negative and negative to positive. Let's have this example so you'll understand it further. Now the first example is 2x minus x. Now same as the adding polynomials, in subtracting polynomials, you have to just subtract it. 2x minus 1x is equals to 1x. The next example, as you can see, we only have x minus 3. There's no like term, so we just have to copy them. X minus 3. Now we're on the third example. We have 2x squared minus x. Same as the second example, there's no like terms, so we just have to copy them. 2x squared minus x. Another example, we have here 2x squared minus 5x minus 2 minus x squared plus 2x plus 1. As you see, we have here like terms, 2x squared and the x squared. We just have to subtract it. We'll have x squared. Now negative 5x minus 2x will have negative 7x. Now negative 2 minus 1 will have negative 3. So the answer is x squared minus 7x minus 3. In this example, we apply the rules in adding and subtracting integers. If you remember it in our first discussion. So we're done in adding and subtracting polynomials. Right now on multiplying polynomials. In multiplying polynomials, multiply the numerical coefficients, then add the exponents. So let's take this example. This example is just easy. So we just have to multiply x to 2x. We will now multiply the numerical coefficient 1 times 2. We will have 2 and add the exponent of the two variables, which is they have both 1. We have x squared. The answer will be 2x squared. Now to the next example, we have negative 2x times 3x. So multiply the two numerical coefficient, negative 2 times 3, we will have negative 6, and add the two variables, the exponent of the two variables, we have x squared. So negative 2x times 3x, we will have negative 6x squared. Now for the third example, as you can see, we have y, but the numerical coefficient of y is 1. So we have to multiply the numerical coefficient. 2 times 1 will have 2. And as for the variables, we just have to combine them since they are not the same variable. We have x, y. The answer will be 2xy. Now for the last example, we have 2x times x minus 3. In this one, we have to apply distributive property. So we will have 2x times x and minus 2x times 3. So multiply the two. We will have 2x squared minus 6x. And the answer is 2x squared minus 6x. Now that's all about polynomials. Now let's have a little review about polynomials. Well, polynomials are algebraic expressions that consist of variables and coefficients. Poly, that means many, and nominal means terms. There are three types: monomial, binomial, and trinomial. And now polynomials can be added, multiplied, and subtract. So in adding polynomials, just add the like terms, and in subtracting, just like adding, subtract the like terms. But you have to change the signs of that subtrahend. And as for multiplying, in multiplying polynomials, just have to multiply the numerical coefficients, then add the exponents of the variables. As you know, polynomials are algebraic expressions. But what is algebraic expressions? Well, it is an expression with an integer constants, variables, and algebraic operations. We have here the example x plus 8. The x is the variable, the operation plus, that can be minus, and we have here the integer that can be negative or positive. Now speaking of algebraic, we have here algebraic equations. There are types of equation: linear equation, quadratic equation, and cubic equation. How can you identify if the equations are linear or quadratic or cubic? We just have to see the degree. When we say degree, it is the highest exponent of the variable in the equations. Now in linear equation, the highest exponent is 1. We have here the x plus 3. And since the exponent of x is only 1, it is linear. And we have the quadratic equations, and the degree is 2. We have x squared plus 5x plus 6 equals 0. Since the exponent of the highest variable is 2, it is a quadratic equations. And for the last example, we have x cubed plus 8x squared plus 21x plus 18. And since cubic equation has the degree of 3, the highest exponent of the variable is 3x squared. That is cubic equation. So let's try solving algebraic equations. We have here the linear equation x plus 6 minus 3. Let's try to find out how to get the answer. Just solve the like terms. We have here x plus x. The answer will be 2x. And 6 minus 3 will have 3. So 2x plus 3. That's how you find the answer. And now for quadratic equation, solving quadratic equation, we will use the method FOIL method. FOIL means first, outside, inside, and last. First means we have to multiply the first terms, and outside we will multiply the two terms from the outside and the inside and multiply the last. Let's proceed to answering this one so you could understand it. So let's start with first in FOIL method. X times x, we will have x squared. Now on the outside, x times 1, we will have x or 1x. Now inside 2 times x, we will have plus 2x. And on the last 2 times 1, we will have 2. And the answer, since it has like terms, we have to add it or solve it. So we'll end up with x squared plus 3x plus 2. And that's the answer. So that's the end of our lessons today. I hope you cope up with our discussions. I will be giving a short quiz about equations. I'll answering algebraic expressions. It will be posted on our Google Classroom. So I hope you learned something today, and thank you for attending. Thank you, learners.